Hello, listeners. Yamina here. Welcome to the Dr. GPCR podcast. I'm very excited to bring you brand new episodes. These are the latest hot off the press. After these, we will take a break for the holidays, during which we will revisit some of our favorite conversations from the past 3 years. Then, in mid January 2024, we will bring you brand new episodes again. If you'd like to join us as a guest, or if you have guest suggestions, please email us at hello@drgpcr.com. Before we dive into this episode, we would like to take a moment to thank our DrGPCR Ecosystem 2023 partners for their support. Domain Therapeutics, GPCR Therapeutics, Design Pharmaceuticals, Montana Molecular, and Orion Biotechnology. We had a blast talking about GPCRs in immuno-oncology at our last Dr. GPCR symposium held November 17th, 2023. With your premium Dr. GPCR Ecosystem membership, you can watch the stimulating conversation with our expert guests. We're already preparing the programming for the 2024 symposia. If you'd like to give a talk or suggest a speaker, please email us at hello@drgpcr.com. We're currently working on the Dr. GPCR University program to provide you courses and content on all aspects of GPCR research and support our community. Our first course will be held live starting January 25th, 2024, by none other than Dr. Terry Kinakin. More details, including the registration form, coming in December 2023. And now, let's dive into this episode. Hello, everyone. This is Yamina from Dr. GPCR, and this afternoon, I'm very excited to have with me Dr. Neil Grimsey. Neil, welcome.
Hi, thank you very much for the invitation.
It's so nice to have you on. I'm very excited to be chatting with you. And before we hit record, we were talking about the Gordon Conference in June, and what an amazing conference it was. We actually were in the same circle chit-chatting with people at one evening, but we didn't get a chance to really interact, and we're going to do that today.
Looking forward to it.
All right, so let's start at the beginning. Would you please introduce yourself and tell us who you are and what do you do?
Yeah, my name's Neil Grimsey. I'm an assistant professor in the College of Pharmacy at the University of Georgia, Athens. I've had a long and winding road to where I am right now, but currently I'm looking at the spatial temporal mapping of biased signaling dynamics and how different physiological pathologies can actually drive GPCR-mediated and GPCR-independent biasing in the signaling profiles. So really kind of how the spatial bias can drive pathologies.
Interesting. That is very interesting. I'll have more questions about that. How did you end up to where you are today?
The short version is I got very lucky when I was a postdoc. I moved over from the UK and started a postdoc position in San Diego. The first position didn't quite work out. And I was lucky enough to join Dr. Duran Trejo's laboratory. And that was my first insight into G protein coupled receptors. Before then, I was lipid biogenesis and nuclear membrane biogenesis. And that started my 20-year journey through G protein coupled receptors and kinase signaling dynamics. So that was really kind of my first soiree into it.
Mm-hmm. And Joanne is fantastic, and San Diego is also an amazing place to spend time. Did you always know that you wanted to become a scientist?
No, funny story. So actually I didn't. It was only when I was about 8 years old and I was in a music class teaching somebody how to read sheet music, and their dad was working in a microbiology lab. And it just kind of sparked my interest a little bit, and I kind of forgot about it until I was in my teens. And it was really kind of only then where I started kind of really wanting to kind of more and more into science. And it was either music or science, and science won out in the end.
Interesting. So your degree, your undergraduate degree was in science, or
yeah.
How did you navigate, going from interest in music to microbiology and then lipids before entering the fabulous world of GPCRs?
Yeah, no, it was again kind of a long winding road. So I started off doing a straight biology degree. That didn't quite work out. After about 2 years, I ended up moving back home, doing some things back in Sudbury and Suffolk in the UK. I was working in dog food packing factories and restaurants, etc., until I got a lucky break and got a volunteer position in a research laboratory, basically a flavors and fragrancing, and that kind of started my pathway back, realizing I didn't want to be a server. I wanted to actually do research.
Mhm.
And it was through that I ended up getting a position at the Cambridge Institute for Medical Research to do my undergraduate research and then my postdoc or graduate studies.
How interesting. Dog food packaging.
Yeah,
Wow.
you've done that, you realize what you don't want to do, at least. Yeah.
Absolutely, absolutely. This is, I feel like everyone has their own journey, which is interesting to capture. Andrew Tobin was, I think, mentioning that he worked in a bank and he was fired. And then he was reading Nature during, I think, economy classes or some financial courses. I feel like all roads lead to GPCRs to some extent. The other thing you mentioned you realized what you didn't like. During my undergrad degree, I used to work on Sundays actually at a grocery store where I would start at 6 in the morning and I was in the bakery section. And every afternoon when I was done on Sundays at 3 p.m., I told myself, oh my God, I'm so happy I'm going back to school on Monday. And that lasted about a year. And then I ended up working as a summer student in the lab, and I was able to negotiate to be able to work 1 day a week in the lab during my undergrad. And I think it was for $50 a day, just so that I don't have to go back and work in the bakery section of the grocery store.
Yeah, no, I'm with you on that one. I think those, as you say, one of those aha moments of what you really want to do is definitely when I got that opportunity to work in. It was in a teaching laboratory, really, the first one. So I was basically setting up the practicals for the undergraduate students. So I hadn't got my undergraduate at the moment, and
Mhm.
then seeing all the undergraduates doing their practicals and going into research labs to
Yeah.
basically learn how to set up the practicals for next year, kind of made me realize what I really wanted to do and kind of helped kind of pivot kind of my mindset so that I can be more kind of focused in research rather than just any old science, as it were.
Yeah. And anything else? Once you first started working in the lab as a scientist and doing research, what was the first topic that you've encountered? You mentioned lipids, but how did you, if you could expand on your journey,
Yeah.
and also if you have any funny stories. I think working in a food packing factory is really unique. Not everybody gets to do that and then work on GPCRs in the end.
Yeah, no, I mean, for me, I started off working on retrograde transport from the Golgi back to the ER in yeast. And in doing that, it kind of set me up as kind of really kind of understanding kind of the intricate dynamics of molecular cloning and kind of yeast cloning dynamics. And that kind of also helped me to try and figure out how to make antibodies for human proteins. And then that segued from looking at retrograde transport into lipid biogenesis with my graduate studies, and really trying to understand how PA phosphatases are being dynamically regulated. And that kind of interest in how post-translational modifications of proteins can really kind of dynamically control cellular function kind of really sparked that interest that I kind of wanted to kind of move forward and keep on studying. And that kind of really kind of led to how I ended up working on the G protein coupled receptors and ubiquitination of GPCRs and how
Mhm.
that can modulate kind of signaling dynamics in cells.
I always enjoyed in undergrad learning more about transporting protein and really producing protein than all the stops these proteins had to make to get the right decorations, the right signals to be targeted to the right place. I think it's a really fascinating mechanism, and we don't think, at least I don't think about it on a regular basis, but when I do, like you just mentioned, I think it's really fascinating. How does the cell know when to produce the protein, where to direct it, and how to decorate it in a way that it ends up in the right compartment is really fascinating. It's not one protein, it's taking care of everything at the same time.
Yeah, exactly. And a lot of those post-translation modifications are still kind of understudied, really. There's a lot of research in it, but they're not really accounted for a lot in the dynamics. And phosphorylation is hugely, but they're so complex, and there's such a wide plethora of modifications. So it's something that we have to keep in mind when you think about protein regulation.
Absolutely, absolutely. So you mentioned that you got into studying GPCRs when you ended up in Joanne's lab. What was one of the first projects that you encountered and worked on there?
Really, it was a long and winding road for trying to understand how ubiquitin was, or why GPCRs are being regulated by the ubiquitin, not just for the degradation, but kind of what it was doing elsewise. So the original project was really, we saw ubiquitination of the GPCRs, but what was it doing? And that was really kind of my postdoctoral project, was to try and delineate that atypical role or unusual role for how ubiquitin could be being added on to GPCRs,
Yeah.
but doesn't actually regulate its trafficking or degradation. And it's really kind of fed into this unique atypical complex for regulating kinase signaling responses.
So interesting. So my next question is, what is your favorite GPCR? But I guess maybe I should ask, is ubiquitin your favorite GPCR modulating protein?
It's my favorite GPCR GPCR modifying protein, but I'm really kind of unbiased in my preferences for GPCRs. So I used to very much be on thrombin receptors, and that was like PAR receptors, and that's the thing. But I would say nowadays I'm really more about how cellular responses can be hijacked by these G protein coupled receptors during disease pathologies, and how that biasing and signaling can drive those pathological outcomes. So more of a almost agnostic towards which GPCR, but more the case that when you solicit a response, how those cellular responses are being mediated by the host kinome.
How did your research evolve from your postdoc to establishing your own independent lab? Where did the idea of looking at how the pathology actually alters or biases the GPCR signaling in general?
I mean, so for the studies that we've been working on, we've really been focusing on how atypical P38 kinase responses are being dynamically regulated. And this was kind of really how it stemmed from the work with Joanne, where we really identified this novel ubiquitin-mediated formation of a signaling complex at the endosome. Now, that kind of initiation kind of then made us realize, well, actually, this atypical pathway is likely being regulated by a host of other physiological paradigms. So when you actually look through the literature, there's 30, 40,000 papers looking at P38 MAP kinases, but actually a very few of them where they're actually looking at this atypical pathway. And I think it's a growing field where we can actually kind of try to dig underneath the carpet a little bit. And whilst there's all this plethora of information out there, I think there's a lot of oversimplification of some of these kinase responses where there's going to be more regulation by a whole host of pathologies.
Do you think it's because the lack of tools to look at this? Okay.
Yeah, it's very much so for this one. So a lot of what I've been doing in my own laboratory is developing the tools to either try and selectively regulate it, or to actually map how these pathways are being regulated. And that's very much the problem where I kind of came in as a junior professor, as okay, I think this is being regulated by a host of different diseases. How do we go about trying to fix that problem? How do we try to understand what these dynamics are, and how are these signaling pathways being selectively modulated?
Yeah, because you mentioned, kinases and P38, and again, it's me being naive at this point. When I think about kinases, I feel like, well, they do all sorts of things, so it's very difficult to pinpoint and really dissect what they do in a natural state when there's no disease, and how is that modified in the disease. And also, again, being GPCR biased, it's just kinase, which I know it's not true. And I have to remind myself that no, actually, we may not know everything about these. And we need the tools to be able to dissect these.
Very much so. I mean, I know I know your interests are very much in targeting the G protein coupled receptor, and I think that has a lot of huge therapeutic potential, obviously, where you can have selective agonists or antagonists to dynamic control a specific G protein coupled receptor. But oftentimes, especially in some of these complex and chronic illnesses, it's not a single ligand that's mediating the pathology. And that's where the power of some of these kinases can play in, where you can actually hit multiple G protein coupled receptor downstream signaling responses and enable us to be able to kind of have a broader outlook for how we can modulate pathology. And that's really
Okay.
kind of where I'm kind of coming from, I guess, is that the thrombin receptors, the prostaglandin receptors, the histamine receptors, they can all modulate the same kind of pathways. How do they intersect inside the cell and modulate that pathology? So,
Which is absolutely valid when you think about it, because typically especially when I used to work in the lab, in academia, it's a different world, but then I was working on my GPC, my favorite GPCR or family of GPCRs, and it was all about dissecting from the top down. And then oftentimes the down was the next effector. So G proteins, beta arrestin, and maybe MAP kinases, but that was about it. But I always try to keep in mind the fact that in one cell you have multiple GPCRs that can be of different families. They have different ligands. And then there is at some point some intersection in their signaling. And kinases are one of the proteins that intersect in the signaling.
no, for sure. There's some really fabulous work out there, right? You anywhere up to 50 to 70 G protein coupled receptors can be expressed on any given cell, if not more. So how are they all intersecting? If they can all bind to G alpha S or G alpha I, how does that mediate cellular responses, and how do you differentiate those outcomes? And I think that might be kind of a major problem in the future, is how do we delineate those kind of selective G protein coupled receptor signal responses when every cell or a lot of cells have multiple G protein coupled receptors expressed at the same time.
Exactly. And the wiring changes based on the pathology, on the length of the pathology, of the type of the pathology. So having the right tools to really look at holistically at the entire cell with its repertoire of GPCRs is a very interesting approach.
Yeah. That's the hope, that eventually we're going to get to that point. Again, building up the tools where we can actually start to really kind of dive deeply into how those cellular responses are modulated, not just in a single cell, but also kind of in a swathe of different types of cell types, and how conserved are these pathways across cellular physiology.
What are the current tools that are available and that you're either working with or hoping to develop that would help advance the understanding of these?
Yeah, so I mean, coming from San Diego, where Jin Zhang is obviously a fabulous pioneer in some of the spatial threat sensors. That's one of the things that we've ended up working on, is developing these P38 threat sensors to actually spatially map where our kinase signaling responses are occurring, and we see a kind of a spatial bias that's conserved across multiple G protein coupled receptors that we believe is modulating pathological outcomes. So those threat-mediated responses can be really insightful. We're now really kind of trying to understand how those downstream signaling responses are controlled, like how we can pinpoint those pathological switch points that drive the disease. So we're kind of moving more into understanding, looking into selective regulators, how we can kind of selectively bias or block particular signaling proteins at particular places within the cell or within particular tissues, and moving forward to try and look at some of these spatial dynamics from a signaling transcriptome as well.
Very interesting. Do you, in addition to the Brett tools or the FRET type of spatial temporal tools that you're using, are there any small molecules or any other tools that you use to modulate or at least try and capture the difference, the bias in there?
Yeah, we've created some selective mutants that we can actually kind of do that using CRISPR and TALEN modifications of cell lines. We are developing some ways to try and selectively target these pathways. Not quite ready for prime time on that yet, but
Okay.
we are working. There are starting to get some really promising results where we can try and bias and selectively inhibit some of these pathways.
Very exciting, yeah, very exciting work, and can't wait for the prime time when this is ready for the public to consume. I also wanted to ask, so you went while you were doing your postdoc, was there any moment where you were wondering if you wanted to go the academic way or the industry way, and how did you decide to become a professor?
That's a very big question. Yeah,
We have
so every student or every postdoc at some point or another questions where are they going to, where are they coming from,
yeah.
what do they want to be? And I know we were talking a little bit about this in Switzerland about how there's a general student mindset at the moment where they're uncertain, where is their place and how we can get to where we want to go. For me, I was once I'd got into my PhD and really kind of started understanding how research works. I couldn't imagine myself wanting to do anything else. And for me, I kind of, you go to bed thinking science, you wake up thinking science, and you just do science the whole time. If you're lucky, you kind of dream about science too. So it's kind of really obsessive in that respect. There are times when things don't work, and I think every scientist will go for a point where it's been 3 months and you've got no positive pieces of data, and you do question your life choices a little bit.
Yeah.
It's whether or not was it a really great idea to kind of go down this path? Wouldn't it have been better to kind of just jump ship, go to industry and earn a ton of cash? But for me, the reward is really the interactions with my peers, the interactions with the students, and to really kind of really push forward my own boundaries. Right. So we are constantly butting up against what we know. And every day you wake up and there's a whole swathe of new publications out there to make you ignorant of the current field. So I think the fun part, the thing that keeps on pushing me to stay in academia is the fact that we can constantly push our boundaries and really kind of push on our knowledge on a daily basis.
And you make a great point. I think it goes back to, in general, a lot of, so let me take 3 steps back. The reason I like to ask these questions is because our audience is typically between the ages of 25 to 40, the majority of it. So we have listeners outside of this tranche, but most of our listeners are in these phases of their careers, either doing a PhD or doing a postdoc. And I like to ask these questions because I would like to get everybody's story so that hopefully when people listen to this, they can either relate to what the guest is saying or to say, well, actually, you just mentioned that you eat, sleep, science, you dream science. And I'm thinking if to your episode, this episode, and says, well, actually, I don't. That's that aha moment for them to kind of think about what do they want to do. Or if it's someone who says, well, I feel the same way, then to encourage them to stay in the path. That's why I was asking about how did you pick and when, and you're right, I questioned as well for a long time, what should I be doing? I did 2 postdocs. That was 8 years.
Yeah.
And it's because I didn't know what I wanted to do. I didn't know what was out there. And I feel like we are at a point, especially when you just have to go online and Google and trying to figure out what are the opportunities. There's more information out there than there was 10 years ago. But it's still always nice to hear other people's story and opinion as to how they came to make the decision for themselves.
No, for sure. I think, as you said, the hard part is that science is inherently built with failure, right?
Yeah.
You do an experiment, you accidentally kind of put your blots in backwards and they transfer it out into the media and you're like, dang it.
Oh.
Right. So it's how do you combat that? And are the failures kind of outnumbered by the joy you get when you do have a success? Now, there's lots of successes in industry too, so that's perhaps kind of a moot point. But for me, I think the environment and the flexibility that we have in academia
Yeah.
kind of really kind of lent that self to my personal lifestyle, where I kind of enjoy being able to kind of come in perhaps a little bit different times and work in the evenings, but then kind of push myself to work hard and almost any time I want to.
Yeah.
It kind of fits with more my lifestyle, I guess.
Yeah, and you make a great point. I think when choosing a career path in general, it's really nice to hear from people who actually are in that career path and to see what is their experience and try, because obviously you can try to work in every 2 or 3 different career paths for a couple of years and then decide which one you want to take. You have to make a decision. And hearing other people's experiences is very important as well.
No, no, for sure. And I think as you said at the start, that once you've done a few different types of jobs, having worked in hotels and restaurants and dog food packing and newspaper deliveries and a range
Yeah.
of other stuff, I know that those kinds of careers are hard, right? They're hard work too. Getting up for breakfast services and doing dinner services. It's not an
Yeah.
easy profession to be in either,
No.
right? So I think once you've gone through that process, you kind of really value the kind of environments you are when you are in this kind of academic, kind of an
Yeah.
intellectual hard work. It's hard, but the exploration and the reward at the end of it of finding out something new, honestly, that's the motivation that keeps me going.
Yeah. For me, it's whenever I'm in my element, like I am right now, it doesn't feel like work.
Yeah,
It's a pleasure to have this. For example, podcast recording podcast episode. Let me take another couple of steps back. For a long time, I didn't know what I wanted to do.
yeah,
I spent a lot of time working in the lab. Don't get me wrong, I really loved working on GPCRs, but towards the last couple of years, I was questioning whether I do actually like running experiments and testing different ligands or different compounds or different molecules on the same system. And I realized that what I like to do is setting up systems, figuring out the quirks, and then handing those off.
yeah.
And but that took a while. And then when I decided to start the Dr. GPCR podcast, I told myself, well, I don't know if I would like it or not. But after recording a couple of episodes, I figured, oh, actually, I really do like this. And I love talking to people. And I hope that that comes through when people are listening to the episodes, because I get to meet someone, I get to talk to them and get to know them a little bit better. And in the end, we become friends. And this is how the network grows.
Yeah.
This is where you can learn about who does what, and then you can ask questions. And in the long run, it may open doors to collaborations where I can say, hey, Neil, you should talk to that person. They're interested in this topic. They're using a really cool technology. Maybe it can help your research. But it's a matter of daring and trying out new things.
I think you hit the nail on the head there. I mean, you have to dare, you have to try, you have to constantly push, right?
Yeah,
Otherwise, you'll get stagnant, and you have to constantly challenge yourself. It's the same thing we say to the students. If you're not struggling a little bit, there's
yeah,
got to be productive struggle, right? Where you're pushing yourself to your limits, and then kind of just pushing that little bit extra to kind
yeah,
of make yourself grow as a person.
yeah, yeah. But it's hard, so let's not. It's just the hardest thing ever, where you
Mhm.
have to get out of your comfort zone and do
No,
something new. Um, I think being kind to yourself in general when you do these things is very important. But then again, it's hard, but that's when you grow as a person.
no, and I think you're totally right. And I think that there's definitely something that we can take from the pandemic that's kind of really sunk home is making sure that you have that good balance between the hard work that you need to do to be successful, but making sure that you kind of have an equilibrium where you can also make sure you carve out time to be at the same time, right? Otherwise,
Yeah,
you end up just losing all of your life just working, and that's okay for some people. That's all they want to do. But I'm
yeah,
definitely someone who likes to have a good kind of work-life balance where I can actually enjoy being with my family at the same time as well.
exactly. How, speaking of work-life balance, how do you balance it all? Well, you have obviously a lab, then you have a family. You have also, I think, as an academic, and you're absolutely right. When you run your own lab, yes, there's difficulties, but then you have the luxury of, starting a little bit later or being able to leave during the day, coming back, and then continuing. And when you're fueled by the passion, it doesn't feel like work. But how do you typically manage to balance the lab and life in general?
Good question too. Yeah, partitioning, I guess, right? You try and carve out time that's sacrosanct, right, for family or for work, and you as much as possible don't let it bleed through.
Yeah,
And for me, there's the few half an hour before school where I make sure that I'm kind of with my daughter Jasmine, who's awesome, who's 9. And then kind of at the end of the day, kind of when I come home, I try to make sure I definitely have like 2 or 3 hours where I can be with the family and we can
yeah,
book, we can do homework, we can just play. And then after she's gone to bed, then I allow myself to go back and do work. And otherwise you just kind of
yeah,
everything's all you have those carved times where you make sure that you're doing something fun to kind of download and de-stress a little bit and then go back in. Doesn't always work, right? There's always going to be times when you can't do that or whether the deadlines creep in, but it's important to make sure that you kind of value those moments. Life is fleeting after all.
Exactly, and I absolutely agree. So this week I came to the realization that I need to design my perfect work week, at least on paper, and to start setting those boundaries for me to have that balance. Now, don't get me wrong, I actually do the same thing as you do in the morning. I have 2 kids. I spend time with them. I love it when I can take them to school. And then we have that, 10 to 15-minute drive, but in the morning. And that just starts off my day really well because I know that they reached their destinations, they had breakfast, and we had a chat. And then the same thing in the afternoon when we get to do homework, we get to read, or we get to be together. Um, but even in those chunks, I've been thinking lately that I need to, wherever possible, obviously, make sure to carve out time to set meetings aside, set the day-to-day routine aside at work, and give myself time to read more and to explore more and dive into topics that I don't typically think about on a daily basis in order to, one, as you mentioned, a little bit download, but at the same time help fuel the everyday running
Yeah,
around.
I fully agree. For me, I tend to take the dogs out for a nice long hike or a walk or something as well. That outside time, it can help a lot to de-stress. Sometimes the science is wriggling around inside your brain whilst you're doing it, but that's okay. Different places, different thoughts. But yeah, even though we read a lot and we do a lot of computer work, I think, I'm definitely someone who still likes to pick up a book and sniff it. It's an old book where you can kind of really smell the history in it. There's something kind of you can't get from a computer screen, and kind of just taking a moment to read something completely different can actually kind of switch off the stresses that you sometimes get from work as well at the end of the day.
Absolutely. And I think it allows you to be more creative when you don't think about work. When I used to work in the lab, the solutions to any problems with experiments came when I was not working.
Yeah, yeah, and that for sure. You have to come at it from several angles. And I think that's again one of the other sides we haven't talked about. One of the rewards from being in an academic institution is the young minds that are coming through there. And I think that's part of the main reason why I love what I do is the seeing people come in knowing almost nothing about G protein coupled receptors or kinases, and at the end of it, they're teaching me things about how to rethink these works. And I think that kind of novelty, that kind of fresh perspective that when they come in is really kind of part of the reason why I'm here as well.
Yeah, and I think it's a really nice thing when you actually get to help people or guide them. I have a friend, and I've been helping them find their path basically to a postdoc. And it's been so rewarding because I didn't, other than reviewing things and giving comments, I didn't do anything, but it's been so nice to see the evolution, writing an application and going from the first draft to the latest version where it's miles away. The person did all the work, but I feel very proud of them. And just by saying, review this or look at this, just made it so much better.
No, I fully agree with you. I think, as a first gen college attendee too, I think, the not having those mentors at home or even not knowing where to reach out to it within the academic system,
Yeah.
it's challenging, right? And I think being able to be there for someone else and help them see how to move forward, it's definitely very rewarding. And I think one of the surprising things was moving from the UK to the US. And I'm still constantly being surprised by how different those systems are and the things that you need to know here, which we weren't prepared for as postdocs, I think. I think that kind of it's definitely nice to be able to kind of share those insights with the next generation, kind of be able to kind of give them that heads up to make sure they don't necessarily go through some of the pit holes I've gone through in the past as well.
Which takes me actually to my next question now that you mentioned it, because I typically ask people especially when they switch continents and they come, from Europe and to the US or the other way around, how was moving to the US for you? How long did it take you to adapt? Any funny stories, any interesting stories in the process of getting used to this system?
I'm so bad at giving funny stories, but I would say it was hard. It was really fun, a lot of it, but in some ways, but it was just challenging, just trying to work out how the systems work, not knowing kind of where to go to buy anything, or kind of even the silly thing of they don't say, yeah, the just the language barriers, people not understanding English accents. It sounds
Yeah.
weird, but Alexa still can't understand me. I have to put on a really dodgy American accent to get understood. But it's tricksy, right? And I think that those first 6 months of just kind of working out kind of where to go to buy things, where to kind of go to get advice, it takes a little bit of time. And I think having a good network of people in the institute that you're in helps a lot to make that transition for sure.
But I think it's absolutely worth it. It's again going back to getting out of your comfort zone. You grow. You grew so it was hard the first 6 months, but you grow so much.
Definitely, definitely. I would, if I had the choice to do it again, I would 100% do it. I think it was one of the best decisions I ever made, was to make that transition from Cambridge over to San Diego,
Mhm.
and kind of really kind of invest in ourselves, myself, and kind of, I mean, San Diego is beautiful anyway, with the
Yeah.
beaches. It's hard not to like it, but the knowledge that you gain, and the experience, and the community of researchers, that really kind of helped a lot.
Yeah, absolutely. All right. Top three aha moments that you had as a scientist that shaped your trajectory.
Top three. First one would be the first time I stepped foot in a research lab, and actually kind of really seeing. So Rainer Duden, back in the UK at Cambridge Institute for Medical Research, he's now in Germany, but he changed my whole perspective, making me realize that the science can be kind of fun, and that you can really kind of push yourself. I think that was phenomenal, that experience. The second one was, I would say, really the work with Joanne, and kind of really kind of the realizing that we were the first people to actually kind of identify this particular pathway, and realizing how you can really shape the field a little bit by having these new discoveries. And I think that Sherlock Holmes aspect of science, where you're the first one to discover something, is fabulous. And for me, I say the last aha moment would just be kind of the moments when I was trying to figure out what to do as an assistant professor. I think um, that productive struggle of trying to work out how you're going to carve a space for yourself, really kind of made me realize how I can shape my own thoughts as I move forward. So the 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 struggle to become a assistant professor actually helped me grow, I think, to become an independent, it was really good.
Lovely. Any advice for young scientists who want to contribute to the field? I think we talked a little bit about it, but if there's anything else.
Just always persist, right? I mean, a lot of science is about testing your mettle, and to be able to kind of work through the problems and realize that despite things not working perhaps on a daily basis, you're growing by the mistakes, where you can work out how to optimize. And I think that kind of productive struggle and that growth aspect, helps you figure out who you want to be and what you want to do, either scientifically or personally. So to keep on pushing, but then to reach out to mentors, and don't live in silence. You have to kind of talk to people and figure out kind of how other people are doing it, and get some inputs from multiple people.
Yeah. How would you look for a mentor? I think this is something that people may not know how to go about.
That's a challenging one. I mean, I think sometimes they naturally kind of pop up. You'll just be meeting someone and you just click, and you end up talking to them kind of more and more. For me, some of my strongest mentors have been people who I wouldn't have expected. They're just people I've met at a conference, who've just happened to connect with scientifically or personally, and they're really good to kind of bounce ideas from. If you're actually pursuing mentorship, I think the best strategy is really kind of to reach out to either peers, who someone who's got a good PI, who someone who's got a good a mentor, and kind of see if you can try and get into contact that way. That sometimes can be a good approach.
Agreed. I think conferences are the best place to interact with people, especially now that we can do it in person again, where you get to meet the person, and if you click on a scientific basis, as you mentioned, or even as a person, on a personal level, I think it can be very rewarding. And I think people should also think about the peer-to-peer mentoring. It's as important as, student versus PI, because peer-to-peer, the generations are closer. Potentially the experiences are not too far from a distant past. If you just finished your PhD and then you're looking to start a postdoc, but then you're talking to someone who's 3-4 years in, it's a really nice dynamic that can form on that end.
Yeah, I wholeheartedly agree. And talk to many people, right? And I think that's the hard part is, especially after people have come back after COVID, there's still a little bit of reticence of actually going out there and talking to people and kind of
Yes.
putting yourself out there in a vulnerable position. I think, sometimes that's the best thing you can do is to just go and ask for help. More often than not, people are liable to say yes.
I think so too, and that has been my experience. I don't know if I've shared this on any podcast recording, but people ask me oftentimes how did you start recording the podcast? And I had this idea by listening to another podcast, and I thought, well, what do I do? So what I did, I put together a list of 20 people. Either I knew them or not, but I knew about them and their science, and I sent them an email and I said, this is what I'd like to do. I'd like to start recording podcasts, talking to scientists and GPCR experts to talk about the stories behind the discoveries in order to inspire junior scientists and also tell these stories, because we actually don't get a chance to talk about these things. And the response was amazing. 90% of people I emailed responded, oh, this is a great idea. 75% of them said, well, I would talk to you. Others said, no, I'm not going to do that, and which I totally respect. And they ended up coming later on because these people were not early adopters. And it's all about putting yourself out there. I think it goes again to the point that the we've been making, is going out of your comfort zone.
Yeah, I fully agree.
It's hard, it's painful, but it's absolutely worth going out of your comfort zone.
Yeah, I think that the best things, the best decisions I've made in my life have definitely come from putting myself out there and kind of, making a point of being uncomfortable. You can only grow in those positions, unfortunately.
Yes, and you mentioned meetings and conferences and talking to people. Well, we were together at the GRC conference in Switzerland, and it was very intense. It was amazing. But even I, at some point, I was like, oh my God, I want to talk to that person, but what am I going to talk to them about? But I had to push myself and just introduce myself, and we had a really quick interaction. But that's all it takes.
Yeah.
Just go out there, say who you are, where you're working, and introduce yourself, and you never know where that interaction might take you.
Yeah, I mean, despite all the uncertainty and the anxiety for talking to a new person, oftentimes they're just the same as you, right? And they're just as shy, perhaps potentially.
Exactly.
It's easy to kind of forget the fact that these big names in the field are real people too. They're not just the science; they are people, and they'll actually generally, more often than not, happy to talk to new scientists as well.
Exactly. Hence one of the goals of this podcast, to really capture the stories and humanize all of us in the field. All right, Neil, last question. If you have job openings in your team, where can people find you?
Yeah, for sure. At the UGA website, the UGA College of Pharmacy. If you look under Neil Grimsey, I'm there. If not, connect up to me in LinkedIn. I'm happy to talk to people through that as well.
Fantastic. With this, I want to thank you for being here. I really enjoyed our conversation.
Thank you very much for the invitation.
Thank you so much. Don't go anywhere. We're going to stop recording and let people wonder what we're talking about after we stop recording.
Thank you so much.
Thank you. Can I ask you a favor? Please subscribe to our YouTube channel. Many of you come back to watch our videos but aren't subscribed. Having more subscribers will help us get you more content. Thank you for joining us and listening to this Dr. GPCR podcast episode. We would like to thank our Dr. GPCR guest, our team members, Attila, Ines, Montserrat, Ivana, Andreina, and Balint. A huge thank you to our 2023 ecosystem partners, Domain Therapeutics, GPCR Therapeutics, Design Pharmaceuticals, Montana Molecular, and Orion Biotechnology. If you like our podcast, leave us a 5-star review on Apple Podcast. You can also leave us a testimonial at drgpcr.com/testimonials and subscribe to our newsletter. Another way to support us is to share your favorite Dr. GPCR program with your network and colleagues. Email us with any questions or suggestions at hello@drgpcr.com. Until next time, stay safe.